you have any questions about TouchDesigner, you can join my Discord to ask me questions and I will do my best to answer them all. Hello everyone, welcome to GemSeed class. So this lesson will give you an effect of laser scanning. To do the effect of laser scanning, for example, after I finished sweeping here, I asked it to come back. Then there is another effect of this dissipation. Okay, so let's start with this. Let's drag in a model first. What I use here is a model of a flower. Then I have a flower model, and then specifically how to map and color the flower model. There is also the format of his point cloud converted to this ply. You can see this tutorial. Okay, and then we're going to create a null in the back. Then I renamed it POS. And then we rendered it first. Here we use a box as a model of our instance. And then create a transform after it. Then change the size of the transfer to a 0.01. Let's make it a little bit smaller, 0.001. And then create a geo. And then throw the pass on the translate op. Then the corresponding XYZ corresponds to RGB. We can see that we have rendered it. Then we create a camera. A light. Then create a render. Then we create a null after render. Render it out. Here, because of the box, it is still quite many points. 24 points. We use sphere here, not box. And then we connect it to the transform, then we see our frame rate coming up, right? Then you can turn it up a little bit, 0.04. A little bit bigger. And then we see our picture now, it's a little bit out of the picture, right? Okay, we create a point transform. Adjust its uniform scale so that it is in the middle of our picture. Okay, and then we can adjust the lighting to give it a side light. Then we go to the light, we find the shadow. Then we increase the shadow pixels a little, according to your own computer situation. And then we create its color, right? Then we create a point file select. And then we throw the point cloud to it. Then the R on the right corresponds to red. Then green. And then blue, it has its color, right? And then we create a math. Why? Because if we look here, if we don't make any changes, it's very white, right? The code form of its data is 0 to 255, but we are in TD. It uses an encoded form of 0 to 1. So we need to adjust its data range in math. We can go to multi and add. We can use it as 1/255. So we can see that its color appears, right? Okay, and then we're going to create another null later and we're going to name it color. Go back a little bit, and then we drag the color into the instance on color op. And then RG and B. Okay. In this way, our flowers will have color. If we want to adjust the color of the flower, we can create a Svagist aftermath to adjust its color. For example, we want it a little brighter, a little more saturated, and we can adjust it according to our own needs. Okay, so now let's move the color a little farther, and then we're going to make the laser. The feeling of scanning is that we use feedback first. And we create a null in front of it. We renamed it start. And it's a starting point for the feedback we're going to use later. Then go to start and then create a feedback. Okay. Then we press the middle mouse button after feedback to create a special. We use this threshold to choose which parts of it will dissipate later. Then we change it first. We change RGB to green, because if we let it dissipate along the y-axis. Okay, and then we create a noise behind this threshold. And then we see this noise, it's mono now, right? We don't want it to be mono because we want the particle spread out to all angles, so we need to turn off the monochrome. Then go to output, change it to input asterisk noise. Then we connect feedback to the second input of noise, and we create a math after it. We make a math. And then we change the multi and add here to a 0.003. Why is that? Because we have very large data here, right? If we directly let it use the value of amplitude to make a feedback, the particle will fly very far at once. So we let it go down a little bit and we just let it go out maybe a little bit at a time. Then change offset to 0. Okay, then we can turn its amplitude to 1. Then we create an add here. And then we connect the math. Then after that, we create a null after add and we rename it end. This is the end of our whole feedback. And then we drag the end to feedback, okay? We can see that these points above 0.5 have dissipated, right? So we can control it. We can control this parameter to achieve its dissipation. Okay, if we want to change back, we need to turn on the reset in the feedback. Switch back now. Turn it off and it's fly away again. Okay, this is actually one of our most important logic. Okay, so I want to adjust this camera now. We can click on the plus in the lower right of this op. And then we can make it move a little bit. Okay, like this, what we're going to do now is the scanning part, and we're going to create a select first. And we use the start image to do it. We use the same threshold. It is a screening effect of dissipation, right? Let's click here. Well, it begins to dissipate at this position, right? Okay, we're going to create a threshold behind it. Then we press the middle mouse button alone to create a multiply. In fact, when these two are multiplied, what is it? What it did was to delete the remaining threshold parts. Right? If we see it, then delete our part. In fact, in my course, part 13, 14, 15 have talked about this. We change RGB here to green. And it is still a change along our y-axis channel. Here we'd better just copy the RGB above directly to second threshold, then select paste bind here. In this case, we only need to change one and change all together. Then similarly, we also copy the threshold parameter. Then we come here, paste bind. In this case, we can change anyone here and he will change it together. Okay, so now we see that what we have chosen here is actually all of these points above, right? We don't want to select so many points because we only want to get the point of a section. So what we need to use in this place is to create another threshold. After this threshold, create another threshold. Okay, so after this threshold, we change the data of threshold 3 to a 0.001. And then, I just forgot to change here, we need to change comparator to not equal. What does not equal do? In fact, we just saw this less, that is to say, less than 0 here, will be chosen by us here. Then not equal, that is to say, as long as it is less than 0, it will be selected by us. Then what we have to do is to increase a little bit soften. Actually, we can see the part of the point cloud that we've captured here, right? We just need to let it have a little bit here. 0.001, just a little bit of this point cloud is enough. For example, here at the threshold, we can adjust this data. This is the entire cross-section. So now our problem is how to convert this point cloud into a three-dimensional line. Right? Three-dimensional line. So here I need to use a plugin made by myself, which is delete 0. We can see that we have finished this point cloud map here. In fact, we can see that there are many small points here. Everything else is transparent, right? So what we actually need to leave here is these little dots of color. And we don't need these transparency points, right? In the back, if we want to render all these points, it would consume a lot of our computer's performance. What we actually need to render is just this small part of the cross-section. And for the other parts, we can see these transparent areas, which is actually a point that overlaps at the world origin of 0, 0, 0. So we need to use this delete 0 plugin, which I made myself. To delete all the other parts. Then we connect it and then we create a null. We can see that there are only 1,766 points left here, which is the point we need. And for the other part, let's see how many points there were before. 10 million. We reduced it from 2 million points to more than 1,700 points. By doing this, we can keep only the part we need the most and avoid using so many computer resources. Alright, now let's do the next thing, turn it back into a model. This place uses the one created before. The plugin is called Points to Line, which can directly convert our point cloud into a three-dimensional model. As it is now, it will connect all these points to achieve a connection effect. Then it can become a connected point that we see on the right now. And through this point, we can render it directly, right? We create a geo on the right. For example, when I adjust it here, in fact, it implements a screening for this part of our picture. So here we can directly create a constant material for it, and it can make a connection here. Or we can give him a red line here, like a red line in my work. Okay, so now we're going to do another interaction, and we're going to adjust the interaction, and we're going to turn up the brightness of the light and make it a little brighter. Okay. We create a keyboard in here, and use it as an input for our interaction. We can control the threshold with input. Let's look at the range of the whole data, which is 1.2 to -1.2. We create a count after the keyboard in. Then we change the range of count to a 0, 1. Then a math is created after it, and it changes its data range of 0 to 1 to a data range of 1.2 to -1.2. Then we go to the back and create a filter which has a smooth transition of data. At the end, we create another null, and then map the data of null to the data of threshold, and we drag it up. At this point, when we press the 1 key on the keyboard, it will trigger the scanning effect. We can make the filter a bit slower. Something like a 5-second scan should be about right. Now it's swept, right? Okay, so what's the next step? We also set several external points at that time. We want to give it the feeling of a laser scanning effect. Here, we'll create something new. Let's first create a crop after null 2. We only need to clip to a single point, so let's change the crop right in the crop to pixel p. And then we just intercept 1 point. As you can see here, let's pause. We have a total of 488 points. At this time, we only intercept the leftmost point, and then we create a null behind it. We convert it to its data using a top2, which is RGB. We know that earlier we saw the R, G, and B values in the point cloud. Their 3 data values correspond to a point of XYZ in 3-dimensional coordinates, right? Okay. Then we create a line at this time, and we use the line to do this. First of all, let's render the line. Let's render it. We see this point, and then we use a material of wireframe here. Then we apply this material, and that way it will have some thickness, and then set it to a red color. Okay. Then we see that point line has 2 points, point A and point B. Which determine the position of the line. So, let's first set a fixed point, for example, by moving it a little to the right. Then we can fix it in this position. And then the second point, point B, which is actually what we map to this position. We map the R value to the x-axis, the B value to the y-axis, then the value of G corresponds to the y-axis, and then the value of B corresponds to the z-axis. Actually, we can see that we've achieved the scanning effect. It will keep changing with us. We actually use wireframe instead of constant. Let's try again so that the effect of scanning can be achieved. Okay, so moving on now, so we've achieved the effect of scanning, right? So it doesn't stay still and looks a bit boring. As long as we add an animation in the geometry, we can see how this code is written, and then multiply it by a 3, make it faster. Then go to the line and it should rotate as well. Click Paste Reference. This way, both will rotate together. Okay, then we can adjust its position again. Okay, then we'll have him scan it again. Okay. Now we've basically achieved the effect of laser scanning, right? So we still remember that in our previous tutorial, what else does it have? There is an effect that appears with the scan and disappears with the scan. Right? How to do this effect? Let's drag it up first. We achieve this by editing the scale in the instance, controlling the size of each particle. So here we're going to create a constant, This constant serves as the initial size for each particle in our model. Then it's a constant, which means that all points are 1, and it doesn't make any difference in size. We change the output here to set resolution only. Then we can see that we actually have a filtering plugin here before. Use the threshold for the filtering component, and then multiply it using the multiply node. For example, in the picture now, all the points have disappeared. This effect is actually what we just saw. The size of all the points is 0. Okay, let's create another null. Then, drag the scale and drop it onto the instance in the geo. The corresponding value would be RR, because we can see that the size along all 3 axes is the same. Okay, let's try it at this time. We have achieved the effect of scanning. Okay, how do we control its dissipation, right? If you have any questions about TouchDesigner, you can join my Discord to ask me questions, and I will do my best to answer them all.